The 1970s marked a turning point in space exploration. The Apollo missions had taken us to the moon. Now, NASA sought a more sustainable way to reach space. The answer was the Space Shuttle program. The goal was to create a reusable spacecraft. Imagine a vehicle that could launch like a rocket but land like a plane. This program promised more frequent and cost-effective access to space. The Space Shuttle was designed to be a versatile workhorse. It would carry astronauts into low Earth orbit. It would also deploy satellites and conduct scientific experiments. The shuttle would even play a crucial role in building the International Space Station. The development of the Space Shuttle was a massive undertaking. Thousands of engineers and scientists across the United States worked tirelessly on this ambitious project. Despite the hurdles, the team at NASA persevered. The Space Shuttle program paved the way for a new era of space exploration, one where humanity would have a more permanent presence beyond Earth. Before any space shuttle could reach orbit, a prototype was needed for testing. This prototype was the Enterprise. It was named after the iconic starship from Star Trek. The Enterprise never went into space. However, it played a vital role in the Space Shuttle program. It was used for crucial flight tests. These tests helped engineers understand how the shuttle would behave during takeoff and landing. The Enterprise was mounted on top of a modified Boeing 747. This allowed the Enterprise to be carried aloft and released for gliding tests. These tests provided invaluable data. The Enterprise became a symbol of the Space Shuttle program. The success of the Enterprise's test flights paved the way for the first orbital mission of the Space Shuttle program. It had validated the shuttle design and proven the feasibility of a reusable spacecraft, ushering in a new chapter in the history of space exploration. On April 12, 1981, the world held its breath. The Space Shuttle Columbia, named after the first American ship to circumnavigate the globe, was ready for launch. On board were astronauts John Young and Robert Crippen. They were about to embark on a historic mission, STS-1, the first orbital flight of the Space Shuttle program. The launch was flawless. Columbia roared into the sky, powered by its 2 solid rocket boosters and 3 main engines. Millions around the world watched on television. Humanity had entered a new era of space travel. Columbia spent 2 days in space, orbiting Earth 36 times. During the mission, Young and Crippen tested the shuttle's systems. They also deployed scientific instruments and conducted experiments. The success of STS-1 was a major triumph for NASA. It demonstrated that the Space Shuttle was a capable and reliable spacecraft. Columbia's safe return to Earth on April 14, 1981, marked a pivotal moment in human history. The Space Shuttle program, with its maiden voyage, had opened the doors to a future filled with possibilities, inspiring generations to come with its audacity and achievement. Section 4. Eyes in the Sky. Deploying satellites for science and communication. The Space Shuttle proved to be an ideal platform for deploying satellites. Its large cargo bay could accommodate a variety of payloads. This capability revolutionized satellite deployment. Before the shuttle, launching satellites was a more complex and expensive endeavor. The shuttle made it more routine and cost-effective. One of the key satellites deployed by the Space Shuttle was the Tracking and Data Relay Satellite, or TDRS. This satellite system revolutionized space communications. It acted as a relay station in space. This allowed for continuous communication with orbiting spacecraft, including the Hubble Space Telescope and the International Space Station. The TDRS system significantly enhanced our ability to conduct scientific research and exploration in space. The shuttle also deployed numerous other scientific satellites. The Space Shuttle's ability to deploy and retrieve satellites made it an invaluable asset for scientific research. The shuttle's contribution to satellite deployment has had a lasting impact on astronomy, Earth sciences, and our understanding of the cosmos as a whole. Section 5. A Cosmic Lens. Hubble's deployment and the shuttle's vital role. In 1990, the Space Shuttle Discovery embarked on a mission that would change our view of the universe forever. It carried the Hubble Space Telescope. This was the most powerful telescope ever built. Deploying Hubble was a complex maneuver. It required the shuttle's robotic arm to carefully lift the telescope from the cargo bay and release it into orbit. The world watched with bated breath. Hubble's deployment was just the beginning of the story. A few years later, a flaw was discovered in the telescope's mirror. This threatened to compromise its observations. Once again, the Space Shuttle came to the rescue. In a series of daring spacewalks, astronauts repaired Hubble in orbit. The repaired Hubble has provided us with breathtaking images of the cosmos. Hubble's observations have revolutionized our understanding of the universe. The partnership between the Shuttle and Hubble stands as a testament to human ingenuity and our relentless pursuit of knowledge about the universe we inhabit. Section 6. Building a home in orbit. The Shuttle and the International Space Station. The International Space Station, or ISS, is one of humanity's greatest achievements. It is a testament to international cooperation and the spirit of exploration. The Space Shuttle played a vital role in the construction of this orbiting laboratory. It transported astronauts, delivered essential components, and helped assemble the station piece by piece. The shuttle's robotic arm was instrumental in this process. It could maneuver large modules with incredible precision. The construction of the ISS was a complex logistical feat. It involved multiple space agencies and countless hours of work, both in space and on Earth. The Space Shuttle served as the primary means of transportation for astronauts and supplies during the station's assembly. It ferried over 100 astronauts from 16 different countries to the ISS. The ISS has been continuously occupied since 2000. The Space Shuttle's contribution to the construction and operation of the ISS is a testament to its versatility and importance in human space exploration. Section 7. Triumph and Tragedy, Engineering Marvels and Unforgettable Losses. The Space Shuttle program was a marvel of engineering. It pushed the boundaries of technology. It also involved inherent risks. The loss of two shuttles, Challenger in 1986 and Columbia in 2003, were stark reminders of the dangers of space travel. These tragedies had a profound impact on the program and the nation. Challenger disintegrated 73 seconds after liftoff. The Columbia disaster occurred during re-entry. The shuttle broke apart over Texas. These tragedies resulted in the loss of 14 astronauts. These events led to extensive investigations and safety reviews. Despite these setbacks, the Space Shuttle program resumed flights. The lessons learned from the Challenger and Columbia disasters led to significant safety improvements. The Space Shuttle program left behind a legacy of innovation, discovery, and unwavering human spirit. It expanded our access to space, advanced scientific knowledge, and inspired generations.